Let's now see how our functions can be input variables. In our language, function can be described as new data type assigned to new variable. When we declare any new function, we assign specific pattern of data type function to that variable. So let's now see in practical example how we can write that pattern as data type of our input variable. We will create new function map string to string, and here we will have two input variables. First variable will have alias input as data type slice of strings, and second input variable will have alias mapper with data type function. That function will have specific pattern. Let's write our input variables. How we can write our second input variable? First, we will write alias. Then we want to specify data type of this input variable. First, we must write reserved word func, and then we must open our brackets. Inside of our function, we must specify inputs and outputs which we want to assign to that type of function so we can create specific pattern. In this function, we want to have one input variable as data type string and one output variable also as data type string. After that, we will write output of our map string to string function, and in this case that will be slice of strings. First thing which we will write inside of our implementation, we will create new variable output as data type slice of strings with the same length as our slice of strings in our input variable. Then, with our for loop and function range, we will iterate over our input variable. Inside of our for loop, we will target specific index place for our output variable, and then on that specific place we will assign new value. Each value will be object as a variable item taken from our input slice, and that item will be processed with our mapper function. That mapper function is alias for our second input variable, which means that function which we set up for our second input variable will process our item object, and after processing, this function will assign new value to our index place inside of our output variable. Then, after that, we will write return function and we will return output variable as output of our function. Let's now see how we can call this function inside of our main function. First, inside of our main function, we will create a new variable plain as data type slice of strings. We will create a new variable list1 and we will call our map string to string function. For our first input variable, we set up our plain variable, but for the second input variable, we must specify specific function with specific pattern, and we must write implementation for that function. So now, on line 18, we created a new function with one input variable as data type string and one output variable as data type string. We can assign this function as our second input variable because this function has the same pattern as our input variable inside of our map string to string function. This function, for every input variable, will add 3 new characters to that specific string. So now, when we print our list1 variable, the output will look like this. As we can see, we add 3 new characters to each of our strings inside of our slice. Also, this second input variable inside of our map string to string function is anonymous function, because this function only exists inside of our call. We don't have global declaration for this specific function. But nevertheless, if we have any global function which can be matched with our pattern for our second input variable, we can assign declaration of that specific function as our second input variable to our map string to string function. Let's write a real example. On line 12, we created a new function add version. This function can be our second input variable inside of our map string to string function, because pattern from our second input variable is matched as pattern of our add version function. The question is how we can assign this global function as our second input variable. We can do that like this. On line 26, we created new variable list2. Then we called our map string to string function and we passed two values. First value will be plain slice, and for the second value we passed only name of our function which we want to pass as our second input variable, and this global function is matched to our pattern for our second input variable. Let's write another example where we will put specific function as our output of another function. For this example, we created two functions, make bigger and make smaller. These functions doesn't have input variables, and output variable, which we will expecting from our function, will have data type string. In this case, we created a new function, make greater, and this function doesn't have inputs. Output of our new function is another function which doesn't have inputs, and output of that function is string. We can't return specific value in our make greater function. Instead of that, we will return function with the same pattern as our output, and inside of block we will specify implementation of that function. For next example, we want to create function without any inputs, and also output of that function will be another function. But this time we will return specific function which we declared on our global scale. We have a new function, make productive, and for the output we have specific function pattern. But now as our return we specified name of our global function which is matched with our output pattern. Here we will return declaration of our make bigger function, because our make bigger function is global function, and in that function we don't have any inputs, and for the output we are expecting one value of data type string. So we proved that we can return our make bigger function declaration as our output. Let's now create another function in which our input and our output variables will be functions. In our new function, make progressive, we have one input variable with alias fn, and data type for that alias is function without inputs and with one output as data type string. Then, for the output of our make progressive function, we have function in which we have no inputs, and for the output we also have one value with data type string. Now, in our return, we just want to pass our input variable through our return function as our output variable. Let's now create real examples of these functions inside of our main. We created a new variable f1, and value of this variable will be output of our make greater function. Our make greater function is function in which we are not expecting specific value as output, and instead of that we are expecting whole another function with implementation. Our f1 variable isn't specific value, but we have another specific function. Because of that, when we want to check type of our f1 function, we can see that output of that print will be function without inputs and with one output as data type string. This means that we cannot print our f1 variable, but instead of that, we can call our f1 variable as function. If we call our f1 variable as function and we print with println function our new value, we can see output as a second function from sector mg. That is exactly the same output from our function which we get from our make greater function. Let's now call our make productive function. We created a new variable f2. That variable will be also new function. When we check type of our f2 function, we will get function without inputs and output will be value of data type string. Our make productive function return us declaration and implementation of our make bigger function. Because of that, when we call our f2 function and we print output of that function, we can see that our output is hello from the biggest section. That is exactly the same output as output of our make bigger function. So in these two cases, we called our functions from another functions. Let's now call our make progressive function. Our make progressive function have one input variable, and that input variable is function with specific pattern. We created our new variable f3, and because we passed our make bigger function as input variable, f3 variable will become function, but function the same as our make bigger function. Now, when we call our f3 function, we can see that we will get output exactly the same like when we called our make bigger function. But now, for this case, we can write our make progressive function in another way. We created new variable f4 and we also called our make progressive function. But now we passed our make smaller function, and this will be approved because our make smaller function is also matched to our input variable pattern, and that pattern is exactly the same like pattern of our make bigger function. Only in this case, our new variable f4 will become make smaller function. When we execute our new f4 function, we can see that output will be exactly the same like when we called our make smaller function. In the next video, we will see how we can write anonymous functions and what we can achieve with them.